So here's our example, and what I've done here is I've actually put the sine law because I know it's a non-right angle triangle, so the only thing that I have right now that I can use is the sine law. Now, the sine law, if you notice, has A, B's, and C's, and my triangle here has D's, E's, and F's. So the first thing I'm going to do is I am going to label my triangle according to the opposite side. So this here would be F, this here would be E, and this would be side D. Okay, so I am going to rewrite the formula, but using those letters. Okay, so it's actually quite easy to do, and I've done it here. So I have um, angle F for side F over angle D, side D, angle E over E. Okay, so now what I'm doing is I'm going to substitute in what I do know. Now the reason I can already tell, the reason I can use the sine law is for a couple different reasons. Well, one reason being it's non-right. And the other is I know angle 35 and I know side F, which is 42. So I know an angle and the side directly across. So that allows me to use this formula. So let's fill in what we do know to our formula and see where we can go from there. So I do know angle F, so I can actually put that actual number in there. So that means that I have the sine of 35 degrees over 42 equals sine of D. I don't know what D is, so I have to leave it as the sine of D. And I do know side D is 64. And then if I look at sine E, I don't know anything about its angle or its side. So I'm not going to use it for right now because I know nothing about it. So now what we have here is we've actually have a ratio that we can actually solve. So what I'm going to do is I'm going to multiply both sides by 64. And by multiplying both sides by 64, what happens is obviously that I'm going to get sine D by itself. Okay, so I'm going to multiply both sides by that. The 64s cancel out on this side, and I'm left with this, and I'm left with sine D on the opposite side. So I have 64 times the sine of 35 divided by 42, and that's not a very straight line. Sine of 35 divided by 42, and that equals sine D. Now I'm finding an angle, which means I'm going to turn this left side into a decimal. And when I do that, I end up with 0.8740 equals my sine of D. Now remember, I have to get my calculator to actually calculate it by doing inverse. So I know that angle D is going to equal the sine inverse of 0.8740. And when I take my calculator, what I end up having is 61 degrees. So what I'm going to do is I'm going to transfer that now into my triangle. So that means I know 61 degrees. Up you go to where I want you to go. Technology is great when it works and not great when it doesn't. I'll make it go up here. Okay, so it's 61 degrees. Now, I'm still interested in angled E and side E. Now what I can do is this is what I need to use. What do I know about that now? Do I have enough information to find this angle? I think I do. The reason being that we know that the sum of the interior angles of a triangle is 180 degrees. So that's what we're going to use to find that. So we're going to go angle E equals 180 minus the 35 degrees that we were given plus the 61 degrees. And when we subtract that, we end up that angle E is actually 84 degrees. So now I know something about the sine of E. So now I can go the sine of 84 degrees over side E has to equal, and I can either use the sine of 35 over 42, or I could use this information that we had here. I'm going to use what they gave me because the chances are that there'll be less opportunity for me to make a mistake. So sine of 35 degrees over 42. And again, what I'm going to do is I'm going to multiply this side by 42 and this side by 42. And what happens, this cancels out, and that's the start. So I have 42 sine of 84 over E equals the sine of 35. Okay, so we're working on getting that by itself. This is one way. I could actually have divided this side and actually got it that way. So what I need to do is, again, I cross multiply and then I have to divide. So I end up with E is 42 sine of 84 divided by the sine of 35. And when we do the arithmetic for this, we end up with 72.8. And I'm going to look at my units. It's in meters. Okay, so now I have, if I put that back into here, we have this angle is 84. This side over here is 72.8. So now we have found all three angles and all three sides. So that question is finished. Okay, let's try another one. Okay, so here is another one. Now remember I said you could use the sine law two different ways. So how about we go and we write it a different way? Now this time I already have A, B's, and C's, so that's great. So let's write it with the sides on the top this time. So we would have A over the sine of A equals B over the sine of B equals C over the sine of C. And just to make sure that I don't get confused on my triangle, I am actually going to label my sides according to my angles so that I am all set up to actually work. Now, when I substitute things in here, I've got a little issue here because remember to use the sine law. I have to know a side and the angle directly across. Now, I'm only given one side, and that's this side here, but I don't know the angle directly across. So that doesn't mean that I give up. It means that they have given me enough information to solve it. So is there some way I can find angle A? Well, actually there is because I know the other two angles. So I can actually find side A, and that's what we'll do first. And you can, for as far as form goes, you can either take it and put it, and my pen doesn't want to go where I want it to put it. I can either write it directly underneath here, or I can do it to the side down underneath my triangle. So angle A is going to equal 180 degrees minus the 57 and the 61. And when I do that, I end up having that equaling 62 degrees. So again, I'm going to put that in my triangle. So that's 62. So now I'm going to substitute the information in. So A is 5. So I have 5 over the sine of 62. B is, I don't know, over the sine of 57. And then I have C over the sine of 61. Now it's totally up to you which one you want to find first. I could find side B or I could find side C. But in both cases, I'm going to use this here that I know both the top and the bottom. Okay, so let's try the first one here. So when I cross multiply here, I end up having B sine of 62 equals 5 times the sine of 57. And to get b by itself, I'm going to divide both sides by the sine of 62. And what we end up having then is we end up that b is approximately equal to 4.7, and this time it's in centimeters. Okay, now what I'm going to do is I'm going to find side C, and I'm going to, as again, use angle A and side A. So just to make life easy, I'm going to rewrite what I know down here with the C values. So we're going to cross multiply and then divide, and that doesn't want to do a lovely, oh, sorry, technology again. It's great when it works, sucky when it's not. All right, so again, if I cross multiply and divide, so I end up having C sine of 62 equals 5 times the sine of 61. Divide both sides by the sine of 62. And remember, the sine goes with the angle. You can't separate it any way other than with a calculator. So that means C is going to equal, in this case when I do my dividing, multiplying and dividing, approximately 5.0 centimeters. So now what we found that this is approximately 5.0 centimeters, and side B was 4.7 centimeters. Okay, and we have all three angles, all three sides. So we're finished solving that triangle. Okay, so some questions for you to do. Although it says homework, it's not homework, it's just seat work for you to do tomorrow. Have fun.